Hi everyone, in this video I will show you how to use auto-neural feature in SAS Enterprise Miner to perform neural network modeling. To understand the concept of neural network and how to implement this machine learning algorithm, please see the video Neural Network Introduction in simple way. That video covers important information that is needed to follow the steps in this video. If you have not subscribed to my channel, please subscribe for more videos about the data mining method and other videos about data analytics and data science. As mentioned before, my video focuses on an easy way to perform neural network without programming. It is a more practical way to conduct neural network research if you do not have a strong background in math, computer science, and programming language. In order to construct and train a neural network model, we have to make some key decisions, including the number of hidden layers, the number of nodes or neurons in each hidden layer, and activation functions for hidden nodes and output nodes. These are not easy decisions to make since there are no straight rules to determine those numbers. SAS Enterprise Miner has an important feature that is auto-neural. This feature runs the searching for us to find optimal solutions, and we do not have to worry about programming. We just need to enter some primary configurations for our model, including the number of hidden layers and nodes, maximum number of iterations, architecture of the network, and how to stop the training. The built-in search features will run the search to find optimal network model for us. But there's a catch. The auto-neural feature does not automatically and always finds the most accurate model. We still need to perform numerous trial and errors until we find the one that works. I will demonstrate this process using a dataset which is airline decision dataset. The dataset has many personal variables related to passengers' demographics and previous flight experience and airline information. The target variable is the airline decision. So we want to develop a model that predicts the passenger's decision to select the same airline again for the next flight. Please see other videos about how to convert an Excel file to a SAS file using SAS Studio and how to create a library and connect it to a folder. I have already uploaded the data file to my folder and created the library connected to that folder. I also created a new project name, Neural Net Example. The first step is to add the dataset to the project. We will right-click on the data sources and select Create Data Source and click Next. In step 2, click Browse to find the folder. On the left, you'll see a library named Trung. That is the library connected to my folder, so I double-click it. It will open my folder and show all SAS files in that folder. I will select the data file name Airline Decision and click OK. Then click Next. In step 3, we see some meta information about the data. We have 22 variables and more than 129,000 observations or rows of data. Yes, it is a big data set. Click Next. In step 4, I will select Advanced to detect variable scales. Click Option. You will see some detail of the advanced property. You can make changes as needed. In this case, I keep those options. Especially make sure that I have Yes for detect class level. The reason is that the dataset has many binary and nominal variables, and I want SAS to detect them. Click OK and click Next. In step 5, you see all variables in the dataset with name, row, and level. Check label to see the full labels of those variables. As you can see, SAS detects numerous binary and nominal variables. The remaining variables should be interval. I'm making some changes to the role and level for some variables. First, I find the variable decision and change its role to target. It is our target variable. Then I make the remaining variables input to include them in the model as predictors. I also check the scales for all variables and change the level for price sensitivity to ordinal because it is like a scales item. Click next. Then we click next 3 more times to finish this process. I have another video explaining in more detail the process of creating a new data source. Please review that video. Now I have a data source named airline decision under data source. I will create a diagram to start the modeling. Right click at diagram and select create diagram. We will call it airline neural net. Then I will create a simple diagram for this project. Again, please see my other videos for how to explore data, variable selection node, data partitions, transformations, imputation, etc. I will import the data set to the diagram. In this video, I will use data partition only. I select 50% for training and 50% for validation. To find the auto neural node, select the tab model up here. Auto neural is the first node. I will drag it to the diagram and connect it to data partition. As you can see, the node has all default values. I will not get into all details of the configurations. You can find all descriptions and explanations from the SAS help document. I'll look at the model options on the left and pay more attention to several configurations. First, the architecture property is about how the neural network model is constructed. We have some options here. Single layer is the default setting in which hidden layers are added in parallel. One or more activation functions can be used. Block layers allow hidden layers to be added as additional layers with a uniform number of neurons or nodes. Funnel layers add hidden nodes both to each existing hidden layer and to a new layer so that the layers form a funnel pattern with a single node feeding into the output node. Finally, cascade adds hidden nodes in a cascading fashion. The next property is train action, which specifies the method that you want to use when training. You can choose to form the following actions. Train means all selected functions are trained until stopping. Increment means nodes are added one at a time. No activation functions is reused. If a layer lowers the average error, it is retained. If that does not, then it's dropped from the model. And search means nodes are added according to the architecture. The best network is retained as a final model. Search is the default setting. As you can see, SAS will run the auto search algorithm based on our configurations to find the best model. We also need to look at the termination property, which specifies the method that you want to use to end training. Note that training always stops when the maximum runtime is exceeded. When training is terminated, the model that has the best selection criteria is retained. We have 3 termination methods. Overfitting means training stops when overfitting is detected. Training error means training stops when the reduction in training dataset error is less than 0.001, and time limit means training stops when the time specified in the total time property is exceeded. The next property is maximum iteration, which specifies the maximum number of iterations permitted during training. Permissible values are any integer between 1 and 50. The default setting is 8. We also look at the number of hidden units, which is the number of hidden units that you want to use. Permissible values are integers between 1 and 8. The default setting is 2. Another one you want to look at is tolerance, which is extent of the preliminary search. Low means no preliminary search is performed. Medium is the default setting and means preliminary statements are executed. High means preliminary statements are executed as well as applying the setting abscons or absolute function convergence criterion equals 0.001 to the training data. For the first autoneural, I keep everything as default settings. Then I add another autoneural node to the diagram and name it autoneural 2. I make some changes to this node. First, I set the architecture to block layers, termination to time limit, and change the maximum iteration to 20. Thus, we could have a bigger network. Then I add another one, autoneural 3. For this one, I change architecture to cascade and freeze connections to yes. This is a common option for cascade structure. Then I add autoneural 4 and make one change. I change train action to increment. Let's add another one, autoneural 5. For this one, I change the maximum iterations to 20 and the number of hidden units to 8. Autoneural 6 will be similar except that we'll use block layers. So I change architecture to block layers, maximum iteration to 20, and number of hidden units to 8. Autoneural 7 will be the same as autoneural 6, except that we'll use increment for train action. So I change train action to increment, architecture to block layers, maximum iteration to 20, and number of hidden units to 8. Note that autoneural has limited properties for us to choose since the software makes a lot of decisions for us. If you want to have more authority to change the settings for the network and configurations, then you should use neural network node. However, this node requires a deeper understanding of the neural network structure, activation functions, and the search optimization model to have good configurations for the model. Otherwise, it will produce a less accurate model compared to autoneural node. To compare these models, I add model comparison node and connect it to all these models. For assessment report, I select yes for ROC chart. For model selection, I select misclassification rate for selection statistic and validation for selection table. To run all models, right-click at model comparison and select run. It will run all models and select the champion model based on our selected criterion. Be patient with the training time. As indicated in my other videos, neural network requires much more computing time to find the network structure. So it will take much longer than other algorithms, such as logistic regression, decision tree, and random forest. I will skip through the waiting time for the purpose of this video, but you should know that it took me about 2 hours to finish the training process. Now we have the results. Let's see them. Right-click on Model Comparison and select Results. It takes a while to open the results as well. First, let's look at fit statistics comparison. Based on the misclassification rate, AutoNeural 6 is a champion model with the lowest misclassification rate for the validation sample, 0.2105, followed by AutoNeural 5. The least accurate one is AutoNeural 3. We also need to examine predictive power to confirm that model comparison. Let's examine RC chart. The closer the curve to the left and top size, the better. If I click on the model down here, the software will highlight the curve for that model. First, I noticed that the RC for training and validation samples are very close, indicating the reliability of the model. Second, models AutoNeural 6 and AutoNeural 5 are close, but ROC for AutoNeural 6 is closer to the edge, and the ROC for AutoNeural 3 is not good. Similarly, we can look at the lift chart. The lift curves for training and validation samples are very consistent, further confirming the reliability. The higher the lift, the better. AutoNeural 6 and 5 have the highest lift. These charts would confirm AutoNeural 6 is a champion model because it has a good predictive power and the lowest misclassification rate. Just to remind you that AutoNeural 6 is a neural network model using block layers with 20 maximum iterations and 8 hidden units. Then we need to further evaluate the performance of the champion model and interpret the network for this model. To do that, I want to look at the results for this model only. Right-click at this node and select Results. We basically see the same things, but only for this model. The misclassification rate of 0.2105 is marginal, but could be considered acceptable depending on the decision maker. The lift chart shows that at 20% of the response, the lift is about 1.7, which is marginal. We can open the classification chart to see more information about the prediction. I go to View, Assessment, and select Classification Chart. I will look at the chart for the validation sample. As you can see visually, the false positive rate is very high, while the false negative rate is low. If you want to see the output in number, go to View and select Table. In this video, I'm not going into detail about interpreting the results. Please see my another video on data mining results presentation. I also want to look at the weights in this neural network model. So I go to View, Model, and select Weights. This window shows us the detailed weights for each relationship with coded color. The color represents a value of weights, with the red shows positive values, the blue shows negative values. You can notice that this model uses 2 hidden layers. Each layer has 8 nodes. This configuration is determined by the search algorithm developed by SAS in this software. If you want to see the actual numbers, go to View and select Table. As you can see, these results are very hard to interpret given the complexity of the network structure. For that reason, I would like to see the variable importance instead, as it can tell me which predictor is more important in predicting the passenger decision and the extent of that effects. As mentioned before, getting the variable importance results in neural network is very tricky. None of these results show us that output. If we use decision tree or random forest, the results will provide the variable importance chart instantly. So I have to use a trick to get what I need. To do so, I add the score node to model comparison. The score node is under Assess tab. Then I add the reporter node to the score node. This node is under Utility tab. For my trick to work, I need to change some properties for the reporter node. Under Train property, I select Summary for nodes and select No for Show All. Then we right-click at the reporter node and select Run. Since all neural network models have been trained, this run will be fairly quick, about 10 minutes. Okay, the run is complete. Right-click and select Results. Now we see the results for this node. To see the full report, select View and the report will open in a PDF file. Let's see some basic information of the model and variables. But what interests me most is this chart, variable importance. As you can see here, type of travel is the most important predictor, followed by age, number of flights per year, airline status, and arrival delay time. As I scroll down, I see the results we had before, such as lift chart, gain chart, and RC chart for the champion model. Now this table is very interesting. Variable attribute importance and cross-tabulations. This table breaks down the predictors by range or category depending on the variable scale, percent of each range or category, and the percent of target variable value corresponding with that predictor. The table does it for all predictors, ranking from the most important one to the least important one. I find this output is much easier to understand. And if I scroll down further, I will see the classification metrics, also called confusion metric here, and the full-fit statistics for the champion model. You can see in this metric the true positive rate is almost 92%, which is high. But the true negative rate is just more than 65%, which is rather low. It can be explained by the high rate of false positive here, which is almost 35%. And finally, you also have a table comparing misclassification rates across all models. Now, you can always add more models with different configurations to see if we can achieve better results. But you should be mindful of the computing time. For example, I want to add one more model to see if I can improve the prediction accuracy. So I add the model AutoNeural 8, which uses block layers with 50 max iterations and 8 hidden inputs. Then I run the model comparison again. You should know that these additional models increase the computing time significantly, much more than the previous models that I ran before. It took me many hours to get the results, not to mention the software gave me running error messages several times. I tried in 3 different computers, 2 Macs and Windows, and ran into the same challenges. As you can imagine, the software has to run through the search with many more permutations to find the optimal network. I'm not showing that long computing time, but you should be aware. One trick that I use is when the software seems to be running for a long time and seem to be freezing, I just close the diagram and reopen, but it does not always work. Finally, I got the results with several tries since the server kept giving me some error messages. My guess is that since I run it on the free cloud-based server, the server is not always reliable. We might be able to get the results faster if we run it with a computer version. So I understand the frustration as I had it too. It was not a good experience for me either, since it took me several days with several tries to get the results. But please be patient with the process. It's a part of the journey that we should try to enjoy. I did make some adjustments to help improve the training process. First, I changed tolerance to low, meaning no preliminary search was performed. Second, I increased the total time to 7 hours to allow the software to run the search longer. The default time is 1 hour, which might limit the training by the software. And here's the results for this AutoNeural 8. Right-click it, model comparison, and select the results. It will take some time to open the results. Let's look at the fit statistic to see model comparison. As you can see, AutoNeural 8 has a misclassification rate of 0.2125, which is still higher than the one for our champion model, AutoNeural 6. We can also look at the RC chart. These two models have very close RC curves. What about lift chart? These two are also very close. In conclusion, these two models have similar predictive power, but AutoNeural 6 has a lower misclassification rate, so it is still the champion model. Accordingly, having more iterations or number of hidden units does not guarantee a better model, but sometimes it is, depending on the data. So we should try different configurations to find the best model. Just be aware of the training time when we increase the max iteration number and the number of hidden units. You may ask a question that if we use AutoNeural feature, which automatically searches for the optimal solution, how come we do not always receive the best model? Good question. If you review my video about neural network introduction, you will remember I mentioned one weakness of neural network is that we may have to deal with the local optimal issues. That means the optimal solution that the software finds is just a local optimum, not the global one. That's the reason why AutoNeural still requires trials and errors to find a good model. Experts in computer science usually attempt to write their own search algorithm for their dataset to find the optimal solution, but it is not the purpose of AutoNeural feature. Overall, neural network is a very popular but complex machine learning algorithm. It does not mean we cannot use it if we do not have a strong background of math and computer science. Tools like AutoNeural allow us to use these algorithms for our predictive modeling on some level. As mentioned before, in order to use the full potential of neural network, it will require deep understanding of the method and programming skills to optimize the search algorithms. Regardless, using AutoNeural can still produce good predictions if we know how to combine multiple configurations. Just be aware of the required computing time. This is the end of this video. I hope it gives you a good demonstration on how to build and run neural network models using SAS Enterprise Miner. Please subscribe to my channel if you have not subscribed. Thank you and bye now.